We're now going to look at multi-product CVP analysis. Now all along we're looking at break-even analysis or CVP analysis when we had one product. Now I want to look at when we have multiple products. So it's multi-product CVP analysis. When a company produces more than one product, we want to see how do we calculate the break-even point. So first we have to come up with assumptions on our multi-product CVP analysis. Already when we did the CVP analysis for one product, we had assumptions. We said our selling price is constant, our costs are linear, and we should always be within the relevant range so that our fixed costs do not change and our variable cost per unit does not change. Now for multi-product CVP analysis, the first assumption is our sales have to be in accordance to a predetermined sales mix. Now what this means is a company should have a predetermined way of selling their product. So let's say a company has product A and B. Then for every 5 units of A, the company also sells 10 units. So this means that whenever a company sells 15 units, 1/3 of that has to be product A, then 2/3 of that has to be product B. So we call that a predetermined sales mix. So that's the first assumption. Then the second assumption, our sales mix has to remain constant. Now, not all products are sold in a particular fashion or in a certain proportion. So this only has to apply to companies that sell at least similar products or complementary products, that at least there's some sort of determination of a proportion that you sell them in. Although it can never remain constant, but at least you can say for every 10 chairs that we sell, we also sell 2 tables. So there is some sort of predetermined mix. So we say that's the first assumption, that there is a predetermined sales mix. The second assumption, we are assuming that it's going to remain constant. So for decision making, we can only use multi-product CVP analysis when we can satisfy the 2 conditions. So it doesn't apply to each and every company, because some companies, there is no way of coming up with a predetermined mix. So just to give an example of a company that is non-existent, let's say a company is selling beds, then it also sells radios. So usually there's no proportion with the number of beds that are sold and the number of radios that are sold. So in that case, you cannot try to use multi-product CVP analysis to make decisions. There has to be at least a correlation on what you're looking at. So an example is maybe whenever you sell chairs, do you also sell the table? So like what we talked about, there is a bit of correlation. So at least you can determine a predetermined mix. So for us to come up with multi-product CVP analysis, there has to be those 2 assumptions. Sales have to be in accordance with the predetermined mix. The mix has to remain constant. So that's the first thing. Then for our syllabus on multi-product CVP analysis, we only require to calculate the break-even point in dollars. We're not going to calculate the break-even point in units. So on one product, when we're looking at CVP analysis for one product, we say the break-even point in dollars is equal to fixed cost, and we say divided by contribution to sales ratio. That was for a single product. Now for multi-products or for multiple products, you're going to have 3 products with different contribution to sales ratios. All those products will be generating contribution. Then we're going to use the contribution to cover the fixed cost. So we have to make an assumption that we have to sell this in a predetermined mix, so that each contribution that is generated from the predetermined mix, we use it to cover the fixed cost. So the only problem that we have now is, since we have more than one product, we're not just going to divide with the contribution to sales ratio. We're going to take our fixed cost, then we find a weighted average contribution to sales ratio. So this is the most important part of multi-product CVP analysis. How do we calculate the weighted average contribution to sales ratio? Now, how we calculate the weighted average contribution to sales ratio? We can do it in 2 ways. So the first way, that's the simple way, we just take our total contribution divided by total sales. Now what this means is, You take the contribution of product A, you multiply by the number of units, you get your total contribution of A. You do the same for B, you get the total contribution of B. You add them together. You also find the total sales of A, the total sales of B. You add them together. So if you have two products, you just say contribution of A plus contribution of B. Say sales of A plus sales of B. The total sales value. So that's how you calculate it. That's one way of calculating it. This is the easiest way. In some cases, the examiner will not give you enough information for us to use method number 1. So only when you're not given enough information to use method number 1, then you have to use method number 2. Now method number 2 says, first we need to determine the proportion of total sales value. So if you have 3 products, first you need to get the total sales. Then you determine their proportion. So you get the proportion of the total sales. You multiply with your individual contribution to sales ratio. Then what you do is you add all the products. So you get the proportion of your total sales, multiply with the individual contribution to sales ratio, then you add the products together. So what we're going to do is we're going to use a question in our textbooks to explain both methods. Then we're going to look at our revision kit to see when is it necessary to use method 2 and when is it necessary to use method 1. So we're going to look at a test your understanding. So it's example 4 in our textbooks. We're on chapter number 5. We're going to start by looking at example 4. So I told you that in the exam, what you do first is read the requirement. Because in most cases, if you read the scenario, then you read the requirement, you're most likely going to go back to the scenario. So the requirement says, calculate the break-even analysis to the nearest 1,000. So calculate the break-even point, in sales revenue to the nearest 1,000. So whenever you get such a question, first we need the formula. So our break-even point in dollars is equal to fixed cost divided by the weighted average contribution to sales ratio. When the question reads, Company A produces product X and product Y. Fixed overhead costs amount to $200,000 each year. The following budget information is available for both products for the next year. So our fixed costs are given. And what we need to determine is the weighted average contribution to sales ratio. So we're going to have a working. So what we want to do is we want to establish our weighted average contribution to sales ratio. So I'm going to use both methods. So I'm going to start with the first method. So method number 1. So for method number 1, we have to first determine our total contribution, then our total sales. We're given our contribution per unit is 20. So we take 20 times 20,000. This is the contribution for product X. And for product Y, we take 15 times 10,000. 15 times 10,000. So it's 20 times 20,000 plus 15 times 10,000. We get 550,000. That's our total contribution, 550,000. Then we need our total sales. Now total sales, we take our selling price, which is 50. So say 50 times 20,000 plus 60 times 10,000. Now our total sales are 1.6 million. So to get our total sales, we say 50 times 20,000, which is 1 million, then plus 60 times 10,000. So that gives us our contribution and our sales. Then to get our contribution to sales ratio, we just take our contribution divided by our sales. So we take 550,000 divided by 1.6 million. So 550,000 divided by 1.6 million. So contribution is 0.34375. So 0.344. Let me just round off. It's going to be 0.344. That's how we get the weighted average contribution to sales ratio using method number 1. So it's quite easy. Take your total contribution, then you take your total sales. You divide your contribution with your sales. You get your contribution to sales ratio, 0.344. Now we're going to do this using method number 2. And we want to see, do we still get the same answer? Now method number 2, it requires us first to get our proportion of total sales value, proportion of total sales value. So product X, the sales value is 50 times the 20,000, which is 1 million. So that's the proportion of X. X has 1 million in sales. Y has 600,000. Then the total is $1,600,000. So to get our proportion, we need to take the 1 million divided by 1.6, the 6 million divided by the 600,000 divided by 1.6 million. So I'll repeat this. On proportion of total sales, first we need to get the total sales of X. The total sales of X, we take 50 times 20,000. Then for Y, we take 60 times 10,000, which is 600,000. We add them together, we get 1.6 million. Then our proportion, we have to take the 1 million divided by 1.6, that's for X. For Y, it's 600,000 divided by 1.6. The next thing that we need is we need the individual contribution to sales ratios. So for product X, our contribution is 20. So 20 divided by 50 is 20 divided by 50. So you can just change that to 0.4. So 20 divided by 50, that's 0.4. Then for X, it's 15 divided by 60. 15 divided by 60, that's the contribution to sales ratio, which is 0.25, 0.4. Now in the exam, there is no need to convert it to decimals, because using your calculator, you can easily just put the fractions. Now once we have all the information, we're going to take our proportion. So we start with X. We take 1 million over 1.6. So yeah, just remove the zeros. Times 0.4, or times 20 over 50. So this is the proportion of total sales times the individual contribution to sales ratio over 600,000 divided by 1.6 multiplied by 15 over 60. So in the exam, it's just much easier to use brackets. So you open your bracket, say 1 million, 1,000 divided by 1.6. 1,000 over 1.6 times 20 over 50. You close your bracket. You say plus 600 over 1.6 times 15 over 60. We get 11 over 32, which is 0.34375. Rounded off is going to be 0.344. So using method 1 and method 2, we still get to the same answer. But method 1 is much easier in this situation because it's quite easy to get our total contribution and our total sales. Now in some scenarios, there is no way you can use method 1. The examiner will give you the proportion of the total sales. You have to figure out the individual contribution to sales ratio. You take your proportion of total sales times your individual contribution to sales ratio. That's how you get your weighted average contribution to sales ratio. So in the exam, the important thing is to get to the answer much faster. So just put brackets. You don't have to get the decimal here, get the decimal here. You just use 1000 divided by 1.6 times 20 over 50, just using your fractions, close bracket plus the other fraction. You go straight to your answer. Now once we have the 0.344, now we can go back to our formula. We take our fixed cost. So our fixed cost at 200,000. It's going to be 200,000 divided by 0.344. 200,000 divided by 0.344. So get 581,395. So to the nearest, we're going to get the 582,000. So here I had quickly rounded off the answer, the 0.344, but our answer should have been 0.34375 before rounding up. So let me just use that 0.34375. And I'm supposed to take 200,000 divided by 0.34375 to get 581,818. You round it off, get to the next thousand, it's 582,000. So when I was calculating here, I had quickly rounded off, so you should keep it as a fraction. It's much easier, as 11 over 32. Then you just use it here. Then you round off on the final answer. Because rounding off earlier is going to give us problem. So here I should have kept it as 0.34375. But that was the answer. I had rounded off. So in the exam, do not round off early. Just it's better to keep it as a fraction. I think as a fraction it was 11 over 32. Let me just check. 11 over 32. 11 over 32. Yeah, it was 11 over 32. So you can just keep it as 11 over 32. You come, you put it here, so that you only round off on the final answer. So here the question said round it off to the nearest thousand. The answer will be 582,000 because it's 581,818. So that's how you calculate your weighted average contribution to sales ratio. So with our multi-product CVP analysis, whether we want to calculate the margin of safety, want to calculate the revenue required to achieve target profit, nothing changes. The only thing we have to use now is the weighted average contribution to sales ratio. So I'm just going to put the formulas on the board. So saying to calculate our break-even point, it's only in dollars. So it's going to be fixed cost divided by weighted average contribution to sales ratio. Then we also might be required to calculate revenue required to achieve target profit. You take your fixed cost plus the target profit. You divide that with the weighted average contribution to sales ratio. If you want your margin of safety, it has to be in revenue. Take your budgeted revenue minus your break-even point in revenue divided by budgeted revenue times 100. So our formula do not change compared to when we had one product. We just have to remember now, since we have multiple products, we need our weighted average contribution to sales ratio. And for our syllabus, we're only going to be calculating the break-even point in dollars. So when we calculate the break-even point, we also have to use this for decision making. So we now want to look at how then do we use this for decision making, because we say there are disadvantages with our assumptions. We are assuming that we're going to sell in a predetermined mix and the mix is going to remain constant. So this break-even point here is not realistic because the mix will not be constant. So that's what we want to now look at. So we're going to use our graph to explain it. So we're only going to look at the profit volume chart to explain this. We're now going to look at a profit volume chart for multiple products. For multiple products, we do not have a break-even chart. We don't have a contribution chart. We're only going to have a profit volume chart. On our profit volume chart, our x-axis is going to be revenue. When we looked at a single product, our x-axis was units, but now it changes because we said for our multi-product CVP analysis, we're only going to calculate the break-even point in revenue. Then our y-axis is going to be our profit or loss. With our previous question that we looked at, our example number 4. On example number 4, we were calculating the break-even point in revenue. And we got our answer as 582,000. But then my question was, to get to the 582,000, we assume that we're going to sell those units in a predetermined sales mix. And the sales mix is going to be constant. Those assumptions are not realistic. So it means the company is not going to break even at 582,000. So now we want to look at, then how are we going to use this for decision making? So for decision making, what the company needs to do is, first, they look at the contribution to sales ratio of their product. So here we have A, B, and C, just an example. So let's say A is a contribution to sales ratio of 0.2, B is a contribution to sales ratio of 0.5, C is a contribution to sales ratio of 0.35. We have to make another assumption. So assumption 1 that we're going to make is, we're going to start by selling the product with the highest contribution to sales ratio. We're going to start by selling the product with the highest contribution to sales ratio, which means we're going to start by selling B, then we sell C, then we sell A. So we're going to start by selling B, we sell C, then we sell A. So it's an assumption here. So what is that going to give us? So because we are assuming that we're going to start by selling the product with the highest contribution to sales ratio, it means that we're going to get our minimum sales required to break even. What we're going to get here is the minimum sales required to break even. So we're going to get the minimum amount, because we're saying we're making an assumption that let's start by selling the product that generates more per dollar of sales, which means we're going to cover our fixed costs much faster. So what do we get? We get the minimum sales required to break even. So obviously our graph always starts with a negative. So the negative here will always be a loss. The loss will be equal to the fixed cost. So how our graph is going to look like? So remember when you did the profit volume chart, I told you that with the profit volume chart, the slope of the line is an indication of the contribution to sales ratio, or the contribution generated. So the steeper the slope, the higher the contribution generated per dollar. So this line here is going to be our B. Then this will be C, then this will be A. The reason here we can tell that B here has the highest slope, the highest gradient. So it means that therefore B is generating more of contribution per dollar. So that's according to our assumption. We want to start with B. So B is the steepest slope, is slanting more to the y-axis, followed by C, then by A. And this point that we get here, when our profit or loss is 0. Now this would be our minimum sales to break even. Is going to be the minimum sales required to break even. The minimum sales required to break even. Then if we join our starting point and our finishing point, what we get there is another break-even point. Now this break-even point, we call it the multi-product break-even point. We call it the multi-product break-even point, because we make an assumption that if we're stuck to the standard, if we sell according to the predetermined mix and it's always constant, this would be the break-even point. But we say this is not realistic because our assumption is not correct. Then now we made another assumption, that let's assume we start by selling the product with the highest contribution to sales ratio. This assumption again is not realistic, but then we'll come to a point why we're making these assumptions. Now let's look at the last assumption. we start by selling the product with the lowest contribution to sales ratio. Now this assumption seems like it doesn't make any logic. Why would we want to start by selling the product with the lowest contribution to sales ratio? Now what that helps us with is, we want to find the maximum revenue to break even. So here we are assuming the worst case scenario that, let's assume that we start by selling the product with the lowest contribution to sales ratio. It means that we're going to cover fixed costs much slower because we start with the product that the lowest contribution to sales ratio. So with these units that we have here, means that we're going to start with A, then we go to C, then lastly we go to B. So we're going to have the maximum revenue required to break even. So if we're going to show it graphically, so now if we to show it graphically now, you notice that the first line here has the least slope, then we go to this one, then the last line has the highest slope. So our first line now here, it's A, then this is C, then this is B. So B has the steepest slope. So here from this graph we can tell that, okay, we start with the product that generates the least contribution, followed by the second one, then the one that is the highest contribution. And the figure that we get here is our break-even point. We're saying this is the maximum revenue required to break even. So now we have three assumptions. We start with the first assumption that sales mix will remain constant, so we have a predetermined mix. This is what gives us the multi-product break-even point. So this is what we're doing on example 4. On example 4, we were calculating the multi-product break-even analysis. Then I gave you another assumption. Since this assumption is not realistic, there is no way we're going to sell this product in a predetermined mix. Then I came up with another assumption. Say, let's assume that we start by selling the product with the highest contribution to sales ratio. We get the minimum sales to break even. Then we had our last assumption that, okay, now let's assume we start by selling the product with the lowest contribution to sales ratio. We get the maximum revenue to break even. Now how this helps the company now is, since all of our assumptions are not realistic, but it gives us an area that we know that between the maximum and the minimum, we're going to break even at some point. Then that will help us for decision making, or that will help us in our decision making. So I'll repeat that. Now since we have discovered a minimum and we have a maximum, we know that yes, our assumptions are not realistic, but then our break-even point has to be between the 2 points, the minimum and the maximum. So that's our profit volume chart for multi-product CVP analysis. So in multi-product CVP analysis, you only have to know that we have one chart, the PV chart. On the PV chart, we say the steeper the slope, the greater the gradient. So we can tell here that the B here is the steepest slope. If we go to our data, we also note it has the highest contribution to sales ratio. We're going to just look at one last graph, again the PV chart, to just further illustrate other aspects. So we're just going to look at now the last PV chart for multi-product CVP analysis. So the examiner can just give you a chart like the one that I've drawn on the board. Then the examiner will tell you to label point A and also to label point B. So labeling point B is easier. So here we can notice that we have multi-products. So line 1, line 2, line 3. It's called line 1, line 2, line 3. Then this line that joins the beginning and the end. We know that B here is our multi-product break-even point. Multi-product break-even point. So that's our point B. It's a multi-product break-even point. The reason is we are assuming that we're going to sell our units at a predetermined mix and the mix is going to be constant. So our line is going to be a straight line. It's our multi-product break-even point. But then line A. Now on line A, we should have first sold certain product, so either M, N or O, then we go to line 2, then line 3. So what I want us to do is to establish that which line here is line 1, which line is line 2, which line is line 3, based on our products. So I said how you do that is you look at the steepness of the slope. Say the steeper the slope, the higher the contribution to sales ratio. So here line 1 and line 2, if you're going to compare them, which line is slanting more to the y-axis? It's definitely line 2. We go to our products. It means that line 2 has to be N here because it is the highest contribution to sales ratio. Then line 3 here has a negative slope. We go to our products. That is, we have a negative contribution to sales ratio. So therefore line 3 here has to be O. Then the first line here has to be M. So what this means is point A. Point A here is the break-even point when products are sold starting with M. So you make an assumption that we start with M, then we sell product N, then lastly we sell product O. So it's the break-even point when we sell product M, then we sell N, and then we sell O. So that's about it on our profit volume charts on multi-product CVP analysis. So what you should grasp from this concept is the steeper the slope, the higher the contribution per unit, or the higher the contribution to sales ratio. So the correct thing is the contribution to sales ratio. So from our PV chart, you can easily identify the product by looking at the steepness of the slope. So that's it on our graphs. Now we're going to look at questions in our revision kit. So we're going to look at questions from single product to multi-product for practice. We're now going to look at the competitive aspect. So we're going to start by looking at question number 115. So question 115 in our revision kit. So earlier on I told you that whenever you get a question, first you read the requirement. Question 115 says, if the change in production method were to take place, the break-even output would be. So here we know that we're looking at the break-even point in units, the break-even point output. And now we can go to the scenario. We're told that R&K company manufactures a product that has a selling price of 14 and variable cost of 6. So that means that the contribution per unit here, it's 14 minus 6, which is $8 per unit. And incurs annual fixed cost of 24,000. So the annual fixed costs are 24,400. So our break-even point would be fixed cost divided by contribution per unit. So we're taking 24,400 divided by 8. 24,400 divided by 8. So break-even point is 3,050 units. Then the question continues, or the scenario continues and says, a new production method is currently under consideration that would increase fixed cost by 30%, but would reduce variable cost to $5. The superior quality of the finished product would enable sales to be increased to 8,500 units per annum at a price of $15 each. Now we have a scenario where our fixed costs are increasing by 30%. So we take 24,400 times 1.3. So that's an increase of 20%, 30%, 31,720. Our contribution now per unit, it's 15 minus 5. 10 gives us 3172 units. So before the change of the production process, our break-even point was 3,050 units. We needed to sell 3,050 units to cover our fixed cost. But now with the introduction of the new process, we now need to sell 3,172 units. So take 3,172 minus 3,050. So our break-even point now is 122 units higher. It's 122 units higher. The break-even point 122 units higher. So the answer for 115 is D. So this is for a single product, so it's quite easy. It's a fixed cost divided by contribution per unit, because we want the break-even point in units. We're given the fixed cost, that we're told that the fixed cost is going to increase by 30%. We just had to increase it by 30%. So that's it on question 115. We're now going to look at the next question, question 116. Now question 116, first we need to look at the requirement. It says, at what level of sales would the annual profit be the same with both production methods? So here we have to first put this down in words. For an old production method, and we have a new production method. We want to look at a situation where profit is the same under both methods. So saying at what level of sales would annual profit be the same? To get to our profit, we know that we take contribution less our fixed cost. So take contribution less our fixed cost. That's how we get to the profit. So under the old production method, our contribution was 8. So take 8 times X, which is the number of units. The fixed costs were 24,400. So this is how you get to the profit. So now we don't know this X number of units that is going to result in us having the same profit. And under the new method, the contribution is 10, so 10X minus. Our fixed costs have increased by 30%. So 24,400 times 1.3, that's 31,720. So here, this X number of units will result in the profit being the same under the old method and the new method. So here we have to think of it logically to say, if profits have to be equal, it means contribution minus fixed cost is equal to contribution minus fixed cost. Our contributions are different, and our fixed costs are different. So we say 8X minus 24,400 is equal to 10X minus 31,720. Then we bring our variables to the same side of the equation. It's going to be 10X minus 8X. Then minus 24,400 plus 31,720. So we have minus 24,400 plus 31,720. So 7,320 is equal to 2x. And we divide both sides by 2. So 7,320 divided by 2. We get 3,660. So x is equal to 3,660. We get 3,660 units. So for number 116, the answer is A. So here we just looked at two questions that involve individual products. So when we did our break-even analysis, we never had a question that was similar to this. But we just have to use the logic that we had to know that to get to our profit is contribution minus fixed cost. That's how we get to profit. So we want the profit under the old production method and the new production method to be equal. So that's how we would get to the answer. So that's 115 and 116. They have to do with individual products. Now we go to the next question. We go to 117. Question 117. Now in question 117, now we're looking at multiple products. Looking at multiple products. So in question 117, it says calculate the monthly break-even sales revenue. So we know for multi-products, our break-even point in dollars is going to be equal to fixed cost divided by weighted average contribution to the sales ratio. And we read the question says, XYZ company sells 3 products. Product X has a contribution to sales ratio of 40, product Y has 30, product Z has 35. The monthly fixed cost is 200,000. And the products are sold in the ratio of 3:7:5. So when you're calculating the multi-product break-even point in dollars, we have to keep in mind that we're making an assumption that this proportion of sales is going to be maintained, the 3:7:5. But remember, we say this is not realistic. But to calculate or to get to the answer here, we have to have that assumption on multi-product CVP analysis. So first we need a working to find the weighted average contribution to sales ratio. We said we have 2 ways of getting the weighted average contribution to sales ratio. One, we can take the total contribution divided by total sales. With this question, it's not possible. There is no way we can get the total contribution. There's no way we can get the total sales. Then it means we have to use method number 2. Method number 2, I said we take the proportion of total sales value multiplied with the individual contribution to sales ratio. We sum them. We find the sum of this. So our proportion is 3:7:5. So say 3 plus 7 plus 5, which is 15. So product X has to be 3/15 multiplied by 40 plus product Y has to be 7/15 times 0.3. Then product Z has to be 5/15 times 0.35. That's how you get the weighted average contribution to sales ratio. So I'll just repeat it. For the weighted average contribution to sales ratio here, we have to use the second method. On the second method, we have to first get the proportion. So here it's 3:7:5. We add this, we get 15. So for product X, the proportion is 3/15. So we take the proportion of total sales value times individual contribution to sales ratio. We sum them all. Then we just go to our calculator. We have to just be opening brackets and closing, then we sum them. So we say open bracket 3/15 times 0.4, close bracket, plus 7/15 times 0.3, close bracket, plus 5/15 times 0.35, then we close the bracket. So you just have to recheck if you put in the figures correctly. So 3/15 times 0.4 plus 7/15 times 0.3 plus 5/15 times 0.35. The answer that we get, I prefer to keep it as a fraction. So it's 101/300. That's the weighted average contribution to sales ratio. It's 101/300. So as a decimal, 0.33666 recurring 6. So I prefer to keep the answer as a fraction, because once I start rounding off here, if I'm going to round off again the answer, I might have problems. So once you get the weighted average contribution to sales ratio, now we can go back to our formula. We look at what are our fixed costs. Our fixed costs are 200,000. So we take our 200,000 divided by 101/300. That's the break-even point in dollars. So we take 200,000 divided by 101/300. So we get 594,059. So it says to the nearest 1,000. So to the nearest 1,000, our answer will be $594,000. So here, this is a classical question of when we can use the second method, the proportion of total sales value times individual contribution to sales ratio. When we looked at our first question, when we were doing multi-product CVP analysis, I had to do it both ways because it was possible to do it in both ways. Now with question 117, there is no way you can use total contribution divided by total sales. You do not have enough information. So therefore you can only use method number 2, proportion of total sales value times the individual contribution to sales ratio. So that's it on number 117. We go to the next question, going to question 108. So question 108, it's on individual products. So the question reads, calculate the budget fixed cost in period 3. So this question is different. It has to do with CVP analysis, but then it's saying calculate the budget fixed cost. And what you just have to do is you have to think which formulas have budgeted fixed cost. So I'm just going to put down formulas that have budgeted fixed cost. Our break-even point in units, we know that it's fixed cost divided by contribution per unit. Another formula that has this, it's again our break-even point in dollars. It's fixed cost divided by our contribution to sales ratio. So any one of those formulas will help me to get the fixed cost. But first you just have to read the question and see what are you given. Now from the question we're told, other company provides a single service to its customers. An analysis of its budget for the year ended 31 December 20x5 shows that in period 3, when the budget activity was 6570 service units with sales value of 72, the margin of safety was 21.015%. The budget contribution to sales ratio of the service is 35%. So here I'm going to choose to use this formula. To say break-even point in units is fixed cost divided by contribution per unit. So in this question I do not have contribution per unit. But because I'm given the budget contribution to sales ratio, so budget contribution sales ratio is 0.35. To get it, it's contribution per unit divided by selling price per unit. So in that question we're given selling price per unit with 72. So we say X is equal to 72. X divided by 72 is equal to 0.35. Therefore we get our value of X. Our value of X will be 72 times 0.35. So the contribution per unit is 25.2. That's our contribution per unit, is 25.2. So I'll just repeat here. So the question wanted us to find the budget fixed cost. So I had to first put in a formula that I know has budget fixed cost, which is break-even point in units is fixed cost divided by contribution per unit. Now after that, now I need to find the break-even point and the contribution per unit. With the information that we're given in the question, we told the selling price, we're given the contribution to sales value. So therefore, it's easy to get your contribution per unit because you know that the contribution to sales ratio is contribution divided by sales. Therefore, contribution per unit is 25.2. So that's one thing down. Now, next thing that I need to identify now, it's my break-even point in units. So to get to my break-even point here, in this question we're given the margin of safety. We know margin of safety, it's your budgeted activity minus break-even point activity divided by budgeted activity times 100, or 20.015%. But here our margin of safety, we can convert it to a decimal, then we can remove the 100 to make it easier on us. We can just, this is equal to 0.21015. So in our margin of safety formula, we can easily find our break-even point because we're given the budget activity. So budget activity is 6570. This is going to be 6570 minus y divided by 6570. It's equal to 0.21015. Then we cross multiply. So we take 6570 times 0.21015. So it's going to be 6570 minus y is equal to 1380.6855. Then we can take the y to the right hand side of the equation, bring the 1380 to the left hand side of the equation. Then our y becomes 6570 minus 1380.6855. So our break-even point here, we get 5189. Break-even point is 5189. So break-even point is 5189. So here, the examiner will give you enough information to maneuver your way around the question. So here, because the examiner gave us the contribution to sales ratio, we could easily get the contribution per unit. Then the examiner gave us the margin of safety, so we could get the break-even point in units. Therefore, our fixed cost is just equal to the break-even point in units times 25.2, which is our contribution per unit. So take our 5189 times 25.2. We get 137.62. So the question says round off to the nearest. So 137.62 is going to be B. So here we get it 137.62. We round it off. We're going to get 131,000. So our answer is going to be B. So that's how you go about questions like question 108. So just make sure that first thing you write the formula that has the variable that you're looking for. Then now you can look at, okay, if you're looking for fixed costs here, you need to first get your contribution per unit. And for more information, which information can we use to get the contribution per unit? Then you notice we have a contribution to sales ratio. You use it to get your contribution per unit. Then use your margin of safety to get your break-even point in units. So that's it on number 108. We go to 107. So for 107, I want you to first try it. So you can stop the video, then you try it, then we can do it together. So looking at 107. Now 107, the requirement says if fixed costs for the period are expected to be 160, the revenue needed to earn a marginal costing profit of 40,000 is. So with this question we want revenue required to achieve target profit. What do? We take our fixed cost plus our target profit divided by weighted average contribution to sales ratio. The reason is because this is multiple products. So whenever we have multiple products, we say we have to determine our weighted average contribution to sales ratio first. So we need working one, weighted average contribution to sales ratio. Either we're going to use method number one, which says total contribution divided by total sales, or we use proportion of total sales divided proportion of total sales multiplied by individual contribution to sales ratio. Now with this question we just given that the ratio of the total sales value is 6:5:4. The contribution to sales ratios are 35, 20 and 30. So in this question again it's impossible to use method 1 because we cannot get the total contribution and we cannot also get the total sales. So we have to use method number 2. So method number 2 is your proportion of the total sales value times your individual contribution to sales ratio. So first we need to determine our proportion. So you add 6:5:4, which is 15. So for F is going to be 6/15 times 0.35 plus 5/15 times 0.2 plus 4/15 times 0.3. That's how you get the weighted average contribution to sales ratio. So I told you in the exam you don't have to do this individually. So if you're using a calculator that is allowable in our exam, either Casio FX or a Sharp EL531, we just have to put brackets and we get to the answer. So here we say 6 divided by 15 times 0.35, close bracket, plus, open bracket, 5 over 15 times 0.2, plus, open bracket, 4 over 15 times 0.3, close your bracket. You get your answer 0.28666. So I prefer to keep it as a fraction. So the fraction is 43 over 150, or you can convert it. But converting it now, if you're going to round off your answer, it might give you problems. So you might get a wrong answer. Now we take our fixed cost. So fixed cost for the period is 160,000 plus 40,000 divided by 43 over 150. So we take 200,000 divided by 43 over 150. So 697,674. So 697,674. And to the nearest thousand, our answer will be 698,000. So here on this question, what was just important was to be able to get our weighted average contribution to sales ratio. And in the exam, you have to use brackets. You get to the answer much faster. You take your proportion of total sales value times individual contribution to sales ratio. So this question is necessary to use the second method. With other questions, if it's possible to use method 1, then that's the easiest method. You have to use method number 1. Now what I want you to do is also try question 112. So you can just stop the video, try question 112. We're now going to look at our last question, question 112. So in question 112, it's a bit different from the other question. It says, the lowest break-even sales value per period, subject to meeting the minimum sales value constraint, is nearest to. On question 107, and the other question that we did, and 117, so in question 117, we're calculating the multi-product break-even point, which is a break-even point if we sell the units at the predetermined mix. So we're making an assumption that we're going to sell the units at the predetermined mix on question 117. So it was our multi-product break-even point. Question 112 says, calculate the lowest break-even sales. So now our assumption have changed now. We need to calculate the lowest break-even. And I told you before, when I was giving you 3 assumptions, said, to calculate the lowest break-even sales, what it means is, we need to start by selling the product with the highest contribution to sales ratio. That means we contribute more per dollar, so we're able to cover our fixed costs much faster. So I'll repeat that. Because we want to get the lowest break-even point, it means that we need to start by selling the product with the highest contribution to sales ratio. Because then we contribute more per dollar, so we're able to cover our fixed costs much faster. So yeah, that's what the examiner is testing us. They're saying calculate the lowest break-even sales. So we're not calculating the multi-product break-even sales. We're calculating the lowest break-even sales. But it says subject to meeting the minimum sales value constraint. So first we have to meet the minimum sales values. So our minimum sales values are 400 for each product. So product E, product F, and the product G. And the contribution to sales ratio is 30%, it's 20%, and it's 25%. And our minimum sales is going to be 400, 400, 400. So here we're making an assumption that first of all we're going to have to sell 400 of each of the units, E, F, and G. That means that E will contribute 400 times 0.3, which is 120. Because remember, our contribution to sales ratio, it's contribution divided by sales. So here our sales is 400. Say 400 times 0.3, we get the 120. Then we say 400 times 0.2. So 400 times 0.2, we get 80. And 400 times 0.25. It's 100. So subject to the minimum conditions, we're going to get a contribution of 300. So we're going to get a contribution of 300, and our fixed costs for the question are 850,000. So I'll repeat this. Here we're saying in this question, we told that we're going to make an assumption that first we have to sell the minimum units, the minimum sales value, which is 400 of each. So if we sell 400 of E, F, and G, E will contribute 120, F will contribute 80, G will contribute 100. So that will reduce our fixed cost. Means the fixed cost remaining will be 550,000. Then after that, now we want the lowest break-even sales. So to get the lowest break-even sales, first we need to start by selling product E because it has the highest contribution. Then we sell G. Then we sell F. So for E here already we have sold 400,000, but the maximum sales is 1,200. So now we have to sell the difference between 1.2 and 400. So the difference is 800. So take 800,000 multiplied by 0.3 to see how much is generated in contribution. So it generates 240,000. I'm going to repeat this again. So first we have to meet the minimum sales condition. So the minimum sales condition is 400 of each. Then what we're doing is we're calculating the contribution from the minimum sales. The contribution is 300. So it goes towards covering our fixed costs. So it reduces our fixed cost from 80 to 550. Now this 550,000, how are we going to cover it is, we want the lowest break-even point, subject to meeting the minimum. So here we've met the minimum. Now to get the lowest break-even point, we have to start by selling the product with the highest contribution, which is E. Then we go to G, then F. So with E, we had already sold 400. The maximum sales is 1.2, then the difference is 800. So take 800 times 0.3, that's 240. Then we go to the next product, it's G. So here, how many fixed costs are left to cover? So it's 550 minus 240. So left with 310,000. Now with G, the maximum sales of G is 1.9. And we've already sold 400. So say 1.9 minus 400. So we have to sell 1.5. Multiply by 0.25. So we take 1.5 million times 0.25. We get 375. Now if we get 375, it means that we have fully covered our fixed costs. Because remember, this is our fixed cost. This is our fixed cost. Now this is giving us 370,000. Now 370,000 fully covers our fixed cost. But that's not what we want. Here we just want to break even. So we only want the contribution to be equal to 300,000 so that we break even. So now we have seen our contribution is 300,000. Then our contribution to sales ratio is 0.25. Now we want to find the sales value. We want to find the sales value. So I'm just going to rub off this first part. So we know contribution to sales is going to be 0.25. Then our contribution is 310. and our sales is going to be 310,000 divided by 0.25. So this only has to be 1,240,000. Now we have to add all our cells. See how much cells do we need. So we need 400 of each, which is 1.2, that's the minimum, plus 800,000 plus 1,240. So we need 3,240. So answer for number 112, that's C. Answer is C. So if you do not fully understand this, you can just replay the video, get the concept. So here what's important to understand is, on multi-product CVP analysis, when we calculate our break-even point, we're making an assumption that our predetermined mix is always going to be constant. That's how we calculate our multi-product CVP, or multi-product break-even point. But then the examiner can ask you different types of questions. Like in this case, is the lowest break-even point. On the other graph that I showed you, the PV chart, I came up with just a scenario where you can start with the second one, you go to the first highest contribution, then the least contribution to sales ratio. So there are many assumptions. We just have to know that all our assumptions are not realistic. So the company will just be trying to determine the minimum and the maximum so that they know that their break-even point is going to be between the minimum and the maximum. So that's it on our computational part. Now we're going to look at the last part. What are the advantages of CVP analysis? Now, first advantages, CVP analysis indicates the lowest amount of activity necessary to prevent loss. Remember, we said our topic is for short-term decision making. So in our CVP analysis, we're able to calculate the break-even point, which is the least amount of cells that we need so that we don't make any losses. So companies do not want to make losses. Companies want to be profitable. So the break-even point is a starting point. Now, break-even point analysis aids in decision making as it explains the relationship between cost, production volume, and returns. And with our limitations, all the assumptions that we stated are limitations. As you noticed, our assumptions are too simplistic. So what we've just been previously doing here, our multi-product CVP analysis, our assumption was we assume that we're going to sell the units in a predetermined sales mix, and we assume that the mix is going to be constant. We say that's not realistic. So those are some of the disadvantages. Then the linearity of total cost and revenue, that's also a disadvantage. Then the efficiency and productivity are unchanged. It's another disadvantage. We're going to have a constant price. It's a disadvantage or a limitation. We assume that we're going to have a constant variable cost. It's another limitation. We assume that we had a constant contribution. We assumed we had a constant fixed cost. All those are limitations of using CVP analysis. So when companies use CVP analysis, they have to use so, knowing that there are limitations to this. In a case where variable costs change, then your break-even point is going to change. In a case where fixed costs step up, then your break-even point is going to change, your margin of safety changes, every other ratio changes. So you have to know that you can only use this based on our assumptions, and those assumptions are the limitation. So this brings us to the end of chapter number 5, our CVP analysis. So if you have any questions, you can send me an email. You can send an email at theinfo@imas.co.za. Then if you have any specific questions, you can also scan the question, you send us through, then we can help you with the question. So that's it on our chapter number 5, CVP analysis.